So homework 5 starts off with factoring a quadratic in two variables with a leading coefficient greater than 1. Before I get too far, I better get the right pen going. And basically I'm factoring the same way as I factored my other quadratic expressions. These ones just have the variables on the end also. So again, I would probably just start off with my two sets of parentheses because I know it came from foiling. Factors of 5x squared would be 5x and x. My signs, plus and a minus. I don't know what order they go in, but I'll move them if I need to. And then I'm going to factor the negative 14y squared. So the only thing, instead of doing 2 and 7, we'd use 7y and 2y, or whatever order it needs to be in. I probably don't want to take the 5 times the 7, so I'll put my 2y over here and my 7y here and go ahead and check that. My outside product would be negative 10xy. My inside product is positive 7xy. Sure enough, negative 10 plus 7 gives me negative 3 in the middle. Number 2, that one's a little bit trickier because I've got that 4x squared, and again, since it's a composite number, it might be 4x and x, but I might want to keep in mind that it could be 2x and 2x. On this one, if you look at it, your signs are both negative. Since the end is positive, they're both the same as the middle, a negative and a negative. So I'm just going to plug them all in there and see what I can do. So, factors of 6y squared.
Two y and 3y.
2y and 3y. And do we want to try the 2 or the 3 first? 3. So 3y and 2y. If I check that, I'm going to get negative 8xy and a negative 3xy. And sure enough, negative 8 plus negative 3 adds up to negative 11. So we don't even have to try the other one or switch anything around. We got the right way. Number 3, same kind of thing. Factors of 2x squared. 2x and x. My signs on this one.
Positive, negative.
Positive and a negative. I don't know which order it is, but if I need to switch it, I will. Factors of 21y squared.
7 and 3.
7y and 3y. We're going to try the 7 first. 7y and 3y. That is going to give me negative 6xy plus 7xy, which is the plus 1. Boy, we're good guessers today. Signs are turning out right. And so that would be my answer. The next ones are factoring the difference of squares in one variable. When we multiplied conjugates, that's how we got the difference of squares. So we know that when we look at it, and we only have 2 terms in our quadratic expression, that most of the time it's either cubes or squares, in this case squares. And so when we factor the difference of squares, we have our 2 sets of parentheses. Factors of w squared, w and w. Factors of the 36 are going to be 6 and 6 because I know that they have to be the same terms. And since they're conjugates, one had a plus and one had a minus because we wanted that middle term to cancel out when we factored it, or foiled it. So if I'm going to factor v squared minus 64, how's that going to factor? V minus 8 and v plus 8. Factors of v squared, v and v. Factors of 64, 8 and 8, and then one has a plus and one has a minus. Doesn't matter which order. Number 6, same thing. They switched the order, but you would want to leave the order as it is because you're probably not going to factor anything that has a negative y squared in it. And so if I factor that, that would factor into 4 minus y and 4 plus y. So factors of 16, 4 and 4. Factors of our y squared, y and y, one with a plus, one with a minus. So factoring z squared minus 9x squared. Again, those are both perfect squares, so factors of z squared would be z and z. Factors of 9x squared, 3x and 3x, and then one's a plus, one's a minus, whatever order you like to put your signs in. So if you're going to factor number 8, which says 9 minus 4x squared, that would factor into
3 minus 2x squared.
3 minus what?
2x squared.
Just 2x, right? It wouldn't have the squared on it. And 3 plus 2x. 2x times 2x is the 4x squared. And number 9, if we have 49x squared minus z squared, that's going to factor into
7x minus z.
and its conjugate, 7x plus z. So 49x squared would be 7x times 7x, and of course z squared is z times z, one with the plus, one with the minus. The next one says factoring a product of a quadratic trinomial and a monomial. It's still got 3 terms, but it's not a quadratic expression yet. But normally when you read and it says factor completely, that should be a big flag that says, oh, there's probably a greatest common factor that I have to take out first, and then I'm going to try to factor what's left. So if I look here, my greatest common factor, if I have 9, 24, and 12, I can divide all those by
3x.
3. 3x cubed, right? Because I can do the lower exponent. If I do x squared, there'd still be an x left in all of them. So I want to do 3x cubed. If I divide that out, 9x to the 5th divided by 3x cubed will give me 3x squared, dividing our numbers and subtracting our coefficients, or dividing our coefficients and subtracting our exponents. 24x to the 4th divided by 3x squared is 8x. And then 12x cubed divided by 3x cubed would give me 4. Now occasionally on the ALEKS program you will not be able to factor the quadratic expression that's left, but most times, probably 9 times out of 10, you are going to be able to. So then we'll factor again. But you will run into a few that won't factor any farther. Factoring the 3x squared plus 8x plus 4. Factors of 3x squared. 3x and x, my signs. Both pluses. And my factors of 4, that when I FOIL it out, I get 8 in the middle. 2 and 2. 6x plus 2x is 8x in the middle. So all of that is going to go in the 3x cubed in front times 3x plus 2 times x plus 2. So number 11, if I'm going to factor that completely, my first thing I want to do is take out my greatest common factor, and my greatest common factor would be 3b to the 5th power, exactly. And you should end up with a quadratic expression, so if you're not, that's a good sign that something's going crazy. When I divide that out, what do I have left in my parentheses? 3b squared minus 11b plus 10. And again, that's probably going to factor out. Most of the time it will. And so if I factor the quadratic expression, factors of 3b squared, 3b and b, my signs, both negative. And factoring my 10 so that I end up with a negative 11 in the middle. And which one do I want first? My 5 first and then my 2? So that I get negative 6v plus negative 5v, which is negative 11v in the middle. And so number 12, factor completely, taking out my greatest common factor first, which would be 2u to the 3rd power, 2u cubed. If I divide that out, I'm going to be left with
U squared. Minus 9U.
Minus 9u minus 5. I didn't leave myself enough room to write, so I'll write over here. Factoring the 2u squared minus 9u minus 5. So factors of 2u squared. 2u and u. My signs,
Positive and negative.
positive and a negative. And my factors of 5. Plus 1 and a minus 5, so that we get negative 10 plus 1, which is the negative 9 in the middle that we want. Factoring completely with the repeated use of the difference of squares formula. Again, it tells me to factor completely, which tells me I'm going to take out a greatest common factor first. This time I should be left with the difference of squares, which I'm going to end up factoring twice by the time I'm done. But if we start here with our greatest common factor, 32 and 2 are both divisible by 2, and they both have a u squared that I can take out. So if I divide by my 2u squared, 16 here, and minus v to the 4th is what's left over on my second term. So both of those things should be perfect squares when you factor that out. Not that on the assessment it's going to tell you that you're doing this problem, but while you're doing it, this will be the difference of perfect squares. Factors of 16, 4, and 4. Factors of v to the 4th would be v to the 2nd and v to the 2nd. One has a plus, one has a minus, and of course the 2u squared is out in front. You cannot factor the sum of perfect squares. Try as you may, you'd have to have that third term in there because you'd have to have the middle term from FOILing it out. So you won't factor the 4 plus v squared, but then on the end you do have the difference of squares, which are going to have you factor a second time. So factors of 4, 2 and 2, factors of v squared, v and v, and of course one has a plus and one has a minus. So 2u squared times 4 plus v squared times 2 plus v times 2 minus v would all have to go in for your answer once you have it factored completely. So number 14 there, if I take out my greatest common factor would be 2x to the third, 2x cubed. And if I divide that out, I'm going to be left with
U to the 4th minus 1.
u to the 4th minus 1. That doesn't cancel out and is gone. It has to be there because if I use my distributive property and there wasn't anything there, I just get my first term and I wouldn't get my second term. But again, you can see we have the difference of perfect squares. U to the 4th minus 1 factors into
U squared plus 1. U squared plus 1.
u squared plus 1 and u squared minus 1. Again, we can't factor the sum of squares, but we would factor that difference of squares. So u squared minus 1 factors into u plus 1 and u minus 1. So we get 2x cubed times u squared plus 1. Whoops, I don't need that parenthesis there. What am I doing? So 2x squared times u squared plus 1 times u plus 1 and u minus 1. And number 15 again says factor completely. The greatest common factor there would be
X to the 3rd.
x to the 3rd. If I divide out my x to the 3rd, I'm left with 81 minus u to the 4th. And so if I factor my difference of perfect squares here, 81 minus u to the 4th factors into 9 minus u squared and 9 plus u squared. And then if I factor the 9 minus u squared, that's going to factor into
plus u.
3 plus u, and 3 minus u. And of course, we still have our 9 plus u squared. Now we have the commutative property, so it doesn't matter which order you have all your factors in, just so you have them all.
Your x has to be cubed, so.
Whoops, my x has to be cubed though. Good catch. X cubed. See, that's what happens when I move over instead of down. Factoring the sum or difference of cubes, in this case with cubes, you can do the sum as well as the difference. When you factor the sum or difference of cubes, you're going to have 2 terms or a binomial in your first set of parentheses, and then you're going to have 3 terms, a trinomial in your second set of parentheses. First thing you're going to do is do the cubed roots of each of those. You will have the same sign in the middle. So the cubed root of 125 is 5, because 5 times 5 times 5 is 125. I'm going to have a minus sign in the middle. The cubed root of 8v to the third would be 2v. When you're doing your second set of parentheses, I like to do the first term and the last term first. What I'm doing is just squaring each of these things that I got in my first set of parentheses. So if I square my 5, I get 25. If I square my negative 2u times negative 2u is a positive 4u, that's a v, is a positive 4v squared. That end term will always be positive because you're squaring something. The middle term is what cancels everything out when you multiply it out. It ends up being the opposite of this product. So this product here would be negative 10v. The opposite of that then would be positive 10v. And for fun, if I were going to check that just to prove that that actually works, I would multiply that out. 5 times 25 is our 125. 5 times 10v is 50v. 5 times 4v squared is 20v squared. Then my negative 2v times the 25 is the negative 50v. Negative 2v times positive 10v is a negative 20v squared. Negative 2v times positive 4v squared is negative 8v to the third power. You can see there my middle terms cancel out, and there's my difference of my perfect cubes. So they'll give you a formula on the LH program. They don't really explain the formula. They just say a minus b and a squared plus ab plus b squared or something to that effect. But that's what we're doing. So whenever we have perfect cubes here, we're going to start by doing our cubed roots. So the cubed root of 27u cubed would be 3u, same sign, so a plus, and then the cubed root of 125 is the same 5 it was on the previous problem. Gosh darn, you ate lunch and now you're napping. If I do my first and my last term, my first term here is going to be, what was that? I'm going to square this, so if I take 3u times 3u, I'm going to get 9u squared. So that 3u times 9u squared is that first term, 27u to the third. And my last term is going to be 25. 5 times 5 is 25. So square the first one, square the last one. My middle term will be negative 15u. The opposite of whatever that product is. So the product would be 15u, so I'm going to put negative 15u in the middle. Whoops, I went too far. And the last one, we're factoring 64y cubed minus 27. So, cubed root of 64y cubed, 4y, minus sign, and cubed root of 27, 3. So, my first term in my second set of parentheses would be 16y squared. My last term will be positive 9. And my middle term, plus 12y. there it is.
How many are we doing?